One receptor shape, three completely different outcomes. It starts the same way every time. A drug binds a G protein-coupled receptor, 7 helices threading through the membrane. That binding event doesn't stay at the surface. It gets transmitted straight through the receptor. And on the inside, something is about to wake up. The G protein swaps out GDP for GTP, and that single swap is the switch. The alpha subunit splits away from the beta-gamma pair, and now it's free to go find a target. Which target it finds depends entirely on which alpha subunit this is, and that's where the story branches. If this alpha subunit is GS, it docks onto adenylyl cyclase and switches it on. That enzyme starts pumping out CMP, and CMP levels climb. That's the GS pathway, stimulatory. But if it's GI instead, it docks onto that same adenylyl cyclase and shuts it down. CMP production slows almost to a stop, same enzyme, opposite effect. That's GI, inhibitory. There's a third path. If the alpha subunit is GQ, it activates a completely different enzyme, phospholipase C. PLC cuts a membrane lipid called CIP₃ right in half, splitting it into two separate second messengers, IP₃ and DAG. IP₃ travels to the sarcoplasmic reticulum and triggers a burst of calcium release into the cell. That calcium teams up with DAG, still waiting in the membrane, and together they switch on protein kinase C. Two messengers, one activated enzyme. So one receptor family, three completely different cellular outcomes. GS turns CMP up. GI turns it down. GQ fires off calcium and PKC. Same binding event at the membrane. The outcome is decided entirely by which G protein is coupled underneath. Know the G protein and you know the drug effect. That's the whole exam question.